Welcome to another video. This is kind of the first in the statistics series that we're just starting. And so the first learning objective is to interpret and construct tables, charts, and diagrams, including frequency tables, bar charts, pie charts, and pictograms for categorical data, vertical line charts for ungrouped, discrete, numerical data, tables and line graphs for time series data, and know their appropriate use. Bit of a long learning objective, but this whole learning objective is just about different ways of representing data and kind of, the possible insights we can gain from that. And so there's a few worked examples along the way, but most of this is just going to be kind of talking through the theory of kind of what each of these are. So before I get started, there's a few terms in here that are kind of quite important just to clarify. Categorical data, that's like, when you categorize data into, some sort of category, I guess. So for example, if you think about, say the activities that are, or the extracurricular activities you can do at your school, right? You might be able to play, say, football, rugby, tennis. You might be able to take, digital photography, filmmaking, and I don't know what else other activities might there be. There might be, debating, or whatever, right? And you could categorize these. You could categorize this into sport. You might be able to categorize this into kind of photography or something, or video making, something like that, or maybe art even. If we had painting as well, etc. And with debating, you might have I don't know kind of what category debating might go in, but we might have a miscellaneous category, a misc. So again, see, we're categorizing, and categorical data is just when we have data that's been categorized in this way. So you might be thinking about, the number of sports the number of sports are available at school. So we think about, how big is the category of sports or MISC. And then we've got the word discrete. Discrete just means it comes in a certain amount or like a fixed amount. So for example, I'll give you an example of something that's discrete. For example, the number of AirPods in the AirPod case is discrete. There's exactly 2 AirPods in it, right? And you can kind of have one AirPod at a time. You can't have half an AirPod, right? So that's an example. Whereas time, for example, is not discrete because you can have you can keep breaking down time into smaller and smaller units. So, for example, you can have a second, you can have half a second, you can have a quarter of a second, and so forth. And you can have the tiniest amount of time, right? Whereas with kind of an AirPod, you can only have an AirPod. You can't have a smaller amount. So discrete just means that there comes a point where it can no longer be broken down. And that's opposed to continuous, so which is something like time or the amount of water you have. You can have half of a liter or 2 liters or a quarter of a liter and so forth, right? You can keep breaking the volume of water down. Whereas the number of laptops you could, that's discrete. Or perhaps something like I'm looking around, like the number of calculators I have. That kind of stuff is usually not discrete. So that's kind of what we talk about there. Or perhaps if you're doing an exam paper, right? The grades you get, that's discrete. You either get an A star, or you get an A, or you get a B, etc. Right? You can't really get an A and a half, for example. Or maybe the grades you get or the marks you get in the paper. So your teacher might give you 36 out of 40, for example. Maybe if you're feeling a bit, they might give you 36 and a half even, but they probably wouldn't give you 36.37589 or something, right? So there comes a point where it can no longer be broken down, so that means it's discrete. Numerical data, just involving numbers. And of course, ungrouped means that you don't group it together. So there's loads of ways of grouping things. Well, in this, what it really means is that, say for example, you have children, right, with a bunch of different age. Let's say you have A, B, C, D, E, and they're all different ages. So A could be, maybe her name is Anna, is 11. B is Bob, who's 13. C is Charlie, who is 14. D is Dan, who is 18, and E is Emily, who is let's say 25. So you could perhaps categorize these first 4 as teenagers. So you can group them as teenagers, perhaps, or even categorize them as teenagers, and you can categorize this one as an adult, and maybe these 2 as an adult, if you would like. You could also group them by saying if you group these first 4, you'd say it kind of lies in the group where the age is less than equal to 18, but more than equal to 11, for example. That's what you categorize there. And so, group there. So that's what we mean by group, when we've kind of got, a range of values that are involved, and you specify that range of values. Whereas a category is more kind of, that kind of involves a bit more than you just knowing the numbers. You kind of have to know that football's a sport, right, to categorize it. So that's compared to a group where it's mainly based on kind of numerical thing. So we have to talk through kind of a few of these. What I'll do is we'll just kind of go through these frequency tables, board charts, pie charts, and pictograms first, and then we'll move on to the second part. So this is a bar chart. It tells you kind of, here it even says, here is a bar chart showing you the number of goals scored in a game by a football team in a season. So, the times they scored 0 goals was 7. The time they scored 1 goal was 8. So I presume 8 matches. And 12 matches, 3 matches, and 4, 6 matches. And so this is basically just what a bar chart is. It's kind of, it tells you something on the x-axis, some sort of kind of either category or kind of, well, this is a category, right? So it's saying, these are the category of 0 is the number of the matches in which there have been 0 goals, for example, and same thing with 1, 2, etc. And on the left, it shows you the frequency that occurs in that category. And a lot of the time, before you have this, you might have a frequency table, or you could at least convert this into a frequency table. So you'd have like the category on the left, and then the frequency on the right. So you'll have frequency and category, so it'd be i.e. kind of the number of goals. So you say, 0, so that's 7 times. 1, that's 8 times. 2, that's 12 times. 3, that's 3 times, and 4 is 6 times. So there you go, that's how you convert something like a bar chart into a frequency table, and you can see how it would happen vice versa. So this is kind of what we do with the bar chart, and most of the time it's, if you present with a bar chart, you either have to draw one out, which, they'll give you something like this, and you have to draw it out, or you kind of have to, read something off and answer some form of question. I saw this weirder question, actually, which isn't too common. And you have to say, write down 3 things that are wrong with this graph. So here's a bar chart showing the scores of 5 students in the math and English tests, and you have to write down 3 things that are wrong with this graph. So this is actually a fairly, it's a weirder question, I guess. So you really have to know how to draw a bar chart properly. So, please pause the video, try spotting these. It might take you a while. It actually took me a surprising amount of time to figure this out. So, especially the third one, I struggled with that. So, please go ahead, pause the video, give this a go. So the first thing, I noticed is that kind of there's no key. So I don't know kind of, which shading results to which test. So for example, is this one math and is this one English, or is this one English and this one math? You can't really tell. So that kind of, without knowing that, you've really kind of limited how much you can know on, how much you can kind of tell, I guess. And how much you can read off from the bar chart, so that's a big limitation. So we can just say no key. And here you can say we do not know which bar is which subject. That's one big thing. Another thing you might notice is kind of, if you look here, this goes up by 4, by 4, by 4, by 4, and then suddenly by 2. So clearly this is some sort of inconsistent scale on the y-axis. So you can say, inconsistent scale on y-axis goes from 16 to 18. So, each of these squares usually represents 4, but suddenly kind of here somehow it only represents 2, which you can see kind of really muddles it up, I guess. So yeah, that's quite a weird thing to do. And the final thing to note is that there's nothing on the y-axis, so no label on y-axis. You'd want to say kind of score, maybe. And if they were being really helpful, they might say what the score was out of. But okay, so this is how we do something like that. So when you do these things, I imagine these are kind of the most consistent errors students make when it comes to drawing bar charts. So make sure you have a key, number 1. Number 2, make sure you have your skills correct. And number 3, get your labels. I think those are the big mistakes students do make. We're going to move on to something else now, which is a pictogram. And it's called a pictogram because it's kind of, there's a picture in it, I guess. And these are kind of fairly, I guess, intuitive to understand what's going on here. There's usually a key telling you what's what. And so the pictogram shows information about the number of pizzas sold on a shop on Monday and Tuesday. Write down the number of pizzas sold on a Monday. Well, one of these circles represents 8 pizzas, so half the circle must represent 4. So that's 8 plus 4, so that's just 12. And on Tuesday, 8 plus 8 plus 4, 16 plus 4, 20. And then on Monday and Tuesday, a total of 24 pizzas were sold. The total number of pizzas sold on Thursday were 3 times the number of pizzas sold on Wednesday. Use this information to complete the pictogram. So clearly, to do this, we have to figure out kind of how many are sold in each day. We can use a bit of algebra because we have some unknowns. We can say let the number. That's supposed to be like a hashtag, which you can just represents a number. It's a short form of saying number. Pizzas sold on Wednesday, BW, and then on Thursday, BT. We know that the number of pizzas sold on Thursday, T, is equal to 3 times the number sold on Wednesday, 3W, and we have the total number is sold as 24, so T plus W is equal to 24. So if T is equal to 3W, if we sub that in, we have 4W is equal to 24, W is equal to 6, which means T is equal to 3 times 6, which is 18. So to draw 6 in this, well, that's going to be, well, if 8 is the total pizza, 6 over 8, well, we need 3/4 of the pizza. So we draw 3/4 of the pizza as best we can. That's 6. Looks a bit like Pac-Man. And then 18 is 8 pizza. So 18, we do 18 divided by 8 to get the number of pizzas we get. 18 divided by 8 is 2 and 2 over 8, so 2 1/4. So we're going to draw 1. Try to keep it in the box. 1, 2 1/4. There you go, and that's that. The next stuff is a pie chart. So the thing with the pie chart is that it tells you kind of the proportion of a total that is each category. So you can see this is categorized, right? Peppers is a category, ham is a category, pineapples is a category, and so is mushrooms. But the thing is, it tells us kind of look the information about the favorite pizza toppings for a group of students. So the pie chart is showing us, say, the proportion of all the students that have been asked, the proportion which are like peppers. So you can kind of tell this is clearly a quarter, right? And half like mushrooms, really weird. And pineapple, oh my god, got none of the nice toppings on here. So you can work out the proportion of students that like each of these. And now you have to kind of, from this, you can deduce some stuff. So just by looking at this pie chart, it's incredibly useful because it tells you exactly what the relative proportions of things. And a lot of the times when you have questions like these, you have to convert into absolute numbers rather than just proportions. So the way you do this is you think about kind of what's the area of the sector compared to the total. And we've done that before, right? We just have to consider the angle in here, and that's what it comes down to. And it even says here angle of sector, which kind of gives it away. So peppers, frequency is 80, and then so the angle of the sector is 90 degrees, right? Which means it's a quarter of the circle. So if 18 is a quarter, that means the total number is, you can just say, if for a quarter circle frequency is equal to 18, then total students is equal to 18 times 4. And what is that, 18 times 4? 72. So now we just think about what fraction each of these of a circle is and then times it by 72, right? So mushrooms, that's clearly, the angle sector is at 180, you can kind of tell. It's a straight line. So 180, that's half the total number of students, so that's 36. Pineapple, oh god, pineapple, so, this is 180, this is 90, this is 40, that makes it 50. So it's 50, so I'll just do 50 divided by 360 times 72. Which is 10, and then ham, 40 divided by 360 times by 72, which is 8. And if we add these all up, if we want the left and the right, so these ones should of course add up to 360, and this should add up to 72. just as a quick check, it's worthwhile doing this. Indeed, it comes to 72, and again comes to 360. And so this is how, I think these are all the four mentioned ones that it wanted us to talk about. So we've talked about frequency tables, done, bar charts, done, pie charts, done, and pictograms for categorical data. So we talked about what that is. Now for ungrouped discrete data, we talk about vertical line charts and tables and line graphs for time series data and know their appropriate uses. So knowing their appropriate uses just comes down to if you see enough of these bar charts and stuff, you figure out when they're used. But in general, so with frequency tables, frequency tables and bar charts very much show the same thing, and so kind of even pie charts in that sense. They're different ways of showing the same information of frequency for categorical data. And kind of bar charts is, I imagine, the most often used one. Pie charts are really good for when you want to highlight the relative proportions of different things, rather than consider absolute numbers. And pictograms, I guess that doesn't come up too often in math, but it might come up more in real life, and kind of when you're trying to convince the public of something, it might be easier to convey stuff in nice pictures. And you see, I feel like a lot more in advertising campaigns, because it's a bit more communicable to the public, I guess, or someone who's not as mathematically literate. But and sometimes it just looks nicer. I think that's mainly kind of the appropriate use. So more often, literally, actually not even more often, if they want you to draw something, they'll tell you which one to use. They wouldn't just be like, do whatever you think is appropriate. They'll say, bar chart, right, pie chart, pictogram. And now we're talking about vertical line charts now. So vertical line charts are actually very similar to bar charts, and you'll see why in a second. Like this, you can see, it's like a bar chart, but with no thickness, I guess. It's just a straight line. And it's for what's it called? Ungrouped discrete data, numerical data. So it's ungrouped because, the numbers are just by themselves, right? So you've got test score and the number of students. So the test scores are not grouped. If they were grouped, you might see, between 30 and 35. That's a grouping, right? But this is just 30, 31, 32. It's discrete because, again, there's no such thing as a 30 and a half for a test score. And yeah, so that's ungrouped discrete. And of course it's numerical and it's data. So you can see how this is used, right? So it says, for the number of students who got, 61, that's, just read off it there. Sorry, it's a bit hard to read off on this, but you can see this is what a vertical line chart would look like. Now we're moving on to line charts with time series data. The big thing about time series data is that it's continuous. So that's why you kind of connect the lines like this. So instead of kind of drawing a straight line at every point, which would be a bit weird, I guess, because you'd just be shading everything underneath here. Because theoretically, every one of these points is actually valid, I guess. So in 2016 and whatever time that was, maybe was that January 2016, the gold price was indeed whatever that value comes out to. So that's why we connect the dots, because each of these values is possible. Whereas if you go back here, if we were to connect kind of the tops of each, that wouldn't make so much sense, because which student got 29 and a half or whatever, that doesn't really make sense. Whereas it does make sense to say, at time between in Jan 2017, 12th Jan 2017 on the 10th hour, in the 5th minute and the 26th second or whatever, right? There was actually a gold price at that point. So that's why we kind of connect the dots, because it kind of shows that every single one of these points is valid. So yeah, this is something you've probably seen before. It's quite a fairly common thing, and yeah, it's just, I guess you just connect the dots, or so, because in real life, you can only measure time, kind of the gold price in so many times. You can't measure it for like every nanosecond or kind of 10 to the negative 20 seconds, right? You might measure the price maybe every second or every minute, but you still kind of connect from one minute to another, because theoretically there was a price of gold at that minute. We just never collected it, but we know kind of it's in between the two values. So that's why we've we've got something like this, and this is a line chart. And you might be asked to plot something like this, or read off the value. That's quite common. You say, what was the price of gold in mid 2016? You can go up and you say that. Or maybe you might be asked to describe the price of gold from from 2016 to end of 2017. So you might say, oh, at the start of 2016, the price of gold increased quite dramatically, and then you say from what to what, maybe to here, and then you say, oh, it fluctuates till maybe what was that mid June, and then shoots back up again to a high of whatever that is, 14. 13, 18 maybe, I don't know, and then you say it fluctuates again, and then kind of drops dramatically back down to whatever that is. So there's a total increase by that much, but the high was much greater. So if you were being asked to describe this, you could do something like that. So hopefully that all made sense in this video. This was kind of covering ways of showing data, especially we've covered, what was it? We've talked about continuous data, we've talked about ungrouped discrete data, and about categorized data. So we've talked about how to represent those kinds of data, and in the next video we'll be talking about representing different kinds of data and some questions like that. So see you guys there.